Hello all, welcome back to another IB Chemistry SLHL video. We're still looking at the topic of structure, but we're looking at structure 1.3.1, which is that emission spectra are produced by atoms emitting photons when electrons in excited states return to lower energy levels. So what is an emission spectra? Let's look into this. To understand emission spectra, some just key ideas that we need to keep in mind is that atoms, these emit photons as they transition from higher to lower energy levels. And a way to understand this is looking at emission spectra with the electromagnetic spectrum, so the EM spectrum. As we know, if we've looked at the emission spectrum before, frequencies, wavelengths, so frequencies, wavelengths, and energies, these all vary. And if we look at visible light, for example, visible light, which is the section of the emissions of the electromagnetic spectrum, that us humans perceive as color, we know that color is dependent on wavelength. A shorter wavelength gives a higher frequency, which gives us, in turn, more energy. So on the visible light spectrum, the color with the highest energy, therefore, is violet. If we look at this inversely, that means the longest wavelength will have the smallest frequency and the lowest energy, which means the color with the least energy would be red. Just some formulas to bring all of this together. The speed of light equals wavelength times frequency. And secondly, energy is equal to Planck's constant, which is a value which will be given to you in the exam. You will not need to memorize this, times, yet again, frequency. So you will need to know how to use these formulas and apply them to questions, but that should be fairly simple. Continuous spectra versus line spectra. So continuous spectra is an unbroken band of colors which contain all wavelengths within a specific range. So an example of this would be when you pass light through a prism and it all diffracts into all these beautiful colors, which we then see coming out the other end. Maybe if you're into Pink Floyd, you may have seen that very famous album cover. And this happens because each color is of a different wavelength, and white light, as we know, contains all colors in the visible spectrum. And differently, your line spectra or atomic emission spectra produces discrete lines, specific colors, which correspond to specific wavelengths. These wavelengths correspond to unique energy levels of an element, because as an element is exposed to heat or to electric discharge, the electrons in the element are excited, which is the term that we have to use, and they are excited to higher energy levels. And at these higher energy levels, they absorb photons. As the energy then lowers, photons are emitted with energies specific to the energy level transitions. So as energy lowers, photons emitted specific to transition. So this is what creates our distinct colored lines when this light is passed through a spectrometer, which is the machine used to carry out this experiment. Thank you very much. That is all for this topic, and I hope that was helpful.